7.1, what is a sampling distribution? This section's video is going to be mostly just me saying definitions, okay? And it's important you write this down, and then I'm going to still talk about these in class because these are going to serve as a basis for future maths that we're going to be doing. So it's really, really important we get these definitions down and know the difference between something, okay? First two definitions of parameter and statistic. A parameter is a number that describes some characteristic of the population, and statistic is a number that describes some characteristic of a sample, which are pretty close together, but there is a little bit of a difference. Before we get to some examples, just a little way you can help remember between the two. Parameter, population, the P's go together. Parameter, population. Statistic, sample, okay? Statistic goes with sample, parameter goes with population. Keep the letters together. An example you might write down is, let's say that I'm hungry, so let's talk about chips, okay? So let's say that Lay's Chip Company has a 3-ounce bag of chips. I don't know what they actually are, but we're going to go with 3 ounces, okay? And they're supposed to contain 3 ounces of chips, right? And let's say some inspectors come in and they say the average is 2.8. They took 50 bags of chips and the average amount of ounces of chips is 2.8. So in my example, 3 ounces would be what? You can write down whatever you want in this area. It's up to you. The 3 ounces is the parameter. Because chip company says all their chips that have contained 3 ounces. Now the sample, though, the statistic, is what? The 2.8 ounces. That was average, right? So when they took us, when the people measuring the sample from it, they took however many chips. What did I say? 50. They took 50 chips out, and the average was 2.8. So that's the statistics. That was this. They took a sample from the whole population. Sampling variability is the value of a statistic varies in repeated random sampling. So just kind of ask the question of if we would take many samples of something, if we were to keep doing the chip thing over and over again, what would happen, right? How are those values alter or change? We might take a large number of samples and then calculate the mean and make the graphs to kind of get an idea and a better sense of the variability of all the samples and that we have taken. Sampling distribution is distribution of values taken by the statistic in all possible samples of the sample size from the same population. Now this might be hard because your population can be very large, but there's ways of simulating which we'll go over when we meet in class next, that you'll be able to visualize. Here's a few more definitions here between distribution of sample data, unbiased estimator, and biased estimator. If you're trying to decipher between what an unbiased estimator and biased estimator is, because there's a pretty big and obvious difference, there's a good example in your book on page 430 where they give you a specific example of what would a bias estimator would look like, because of pretty much what the definition says. When the mean of the sampling distribution is different than the parameter, there's definitely some bias, right? Final definitions: variability of a statistic described by the spread of a sampling distribution. The spread is determined mainly by the size of the sample. Remember, just like we've been going over since pretty much the beginning of this course, the larger the sample, the less variability, and the spread is much smaller. Now, as you take a larger sample, you will not eliminate bias because you do not do not have the whole population. Okay, so you get increasing your spread is still going to have some bias, but you will reduce your availability, which is a good thing, making your data a little bit more accurate. When we meet in class, we will show you a bunch of graphs and we'll discuss this, and particularly with regard to difference between statistic and parameter, and veer off from there. I appreciate you watching, and we'll see you in class.